So the second, which is the combinatorial testing. Okay, guys, you see now we go first random. That's why I told you we forget to put slide about the random testing. And then we go a little bit, it's to enhance the testing techniques, which is go to the partition testing. And then now equivalent partition testing, boundaries, which is also, it's better than boundaries, about equivalent partitions. Now we go for something I think is better, which is combinatorial testing. Combinatorial testing. Now, in the previous techniques, which is we have the input, right? And then we test the input. For example, we have input X, we test it. So we take some tests or test cases from that input. Now we have another input. Suppose we have another input, X2, okay? And then I want to test this one. So using the previous or based on the previous techniques, I will create valid and invalid, and then I will select one test cases or test case for that input. If we have another input, I will do the same. For the combinatorial testing, they think if I test only, not they think actually, based on some result or some studies, and I know that studies, they say if we test each one, if we test, for example, X of, let's say we have more than 3, okay? I mean, this is the input. So we have input, this is input, okay? Maybe this can be username, the password, and this is the click the buttons. So we have many input. So if I use now, I test using the previous methods X, I will test it, buzz, okay, done. Now the next buzz, okay, done. The third one, buzz, done. So I finish. So in combinatorial testing, they don't believe in this things. They say we have to test each combinations. Each combination means that I have to test X1 with X2 because they believe that the interaction between the inputs is cause the problem or cause the defect. Okay, this is the idea. The interaction between the inputs, it will cause the defects rather than the input itself. Means now if you have your user, for example, your phone. So if you open, for example, the Wi-Fi, okay, so you tested its work, and then you opened also the data mobile, you tested its work. But now if suppose, okay, you open both together, what will happen? It will work or not? So this is the idea. The combination of two inputs or more than one inputs is cause the errors. So this is the idea of the combinatorial testing. Okay, and this is what they say here. The combinations of multiple inputs, it's called the error. So they propose this combinatorial testing. So in combinatorial testing, we have many methods. We'll see. This is what I explained. I think I don't need to. Okay. Specific combinations. As we see, specific combination means not only the input of X. No, I have to, for example, this case should include, for example, X1 and X2 together, not only X1. And then I test it all, and then I finish test 2 and test all. No, I have to test together, and this is the correct way. So here is the idea. We have input 1 or input A, P, C, D. So I have to, my test case should include, for example, one from here, one from here, one from here, one from here, and test it together, and test it together, test it together. To the combinatorial testing. Okay, we have many methods. As we say, one of them is the all combinations, which is also we can call it is exhaustive testing. All combinations, all the possible combinations of the inputs. Okay, we have, for example, if we have X1, X2, and X1 can take true or false, and this is also true or false. We can, let's say 0, 1, 0, 1. So all the combination here, what? How many first? How many combination we have? We have 4 combinations, because I have to test all the combination 0, 0, right? Which is true, true, or false, 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 true, true, false, and true, true. So this is all the combination. This is the first strategy. I think it's easy. This one just needs some calculations to do it. Because also, but this is also, it's impossible. Not impossible, it's hard to do it, especially for big application. So we have the other one, which is pairwise or T-wise testing or T-way testing. This one, no need to test all these combinations. No need to test all. But here is already pairwise. By the way, this is already pairwise. This is maybe it's clear for if you have three exam or three input. Okay, so in pairwise, each pair from the name pair. Okay, each pair. So you don't have to test. For example, if we say all combinations, so we have to test all the three together. So here, each pair means that you have test cases. The test cases, for example, should be also three, right? Should be three. But your test cases should include at least all pairs together. For that means I have to test A with B. I have to test, or not A with B, X1 with X2, also X1 with X1 with X3. This is the first pair. The first pair, which is X1 and X2. The second pair, which is X1 with X3. Also, we should also test X. I'm talking about the value, huh? So X2 with X3. So this is all pairs. I should test the possible value of these combinations. So this is the input or the name of the parameter of the input, but the possible value is more than this. The possible value, each one should have now 4, based on this example, 4 possible. And this is 4 possible, and this is 4 possible. So I have to test these 12 possibilities. Decision table actually based on the rule of the business. So it's not that's not this. This is the coverage. We can say the coverage here is bears. The coverage is the bears, but this one there is no coverage, and just is based on the rule, business rule. So guys, we'll go through this one by one. I hope we can finish on time. So okay, combinatorial testing, as I mentioned, it's based on the this is example immediately. Okay, combinatorial testing. We have to add maybe one slide here. As I explained, it's based on. No need to add. This is the slide. So this is the example. Okay, example. So here an example of combinatorial testing. And for example, now we have in this this window we have which is find page. So we have, for example, to input the text that you want to search about. We have, for example, here 2 or 3 possible input. 3 possible input. So you may insert uppercase or lowercase or mix between them. So this is the first options of the first input. So we have here also is only 2 inputs, which is the case here. Find the match. The match which should be either is match or don't match. I mean, either click this or don't click. So the search backward also click or not click. That means only two. So then the result, the search result is found or not found. So this is all the possibilities that we have, all the option of this window, right? This is the last one. If you see, is the expected result, found or not found, found or not found. So when we talk now about the combinatorial testing, we have to include all the combinations, all the possible combinations. Means that I have to have combinations, which is, for example, the upper with the match with normal with is found. And then we have the combination with upper match, normal, and not found. We have the combination. So if all these combinations should be tested. So this is what we mean by the combinatorial testing. So let's see the first one, which is all combinations. Here is all the combinations. So if we just say, here we say is U, and this is L, and this is M. Okay, this is match and don't match. For example, I'm not sure what they write it there. Match, yes or no. Okay. And this is yes. The values is yes or no. And the value here is N or P. N or B, the value here also yes or no. Okay, so all the combination, just to simplify the window or this table. So all combinations here, all the combination, that means I have to test all of them. So if you see here now, we have here the first combination, we test the upper, and then it's yes match, and then the direction is forward, I think. Direction is normal and backward, normal or backward. So we test all. This is now is include all the combinations, all the possibilities, all the possibilities. Okay. So guys, maybe it's better to give you an example if we see all the combinations. If you see here, this is now when we have two example or two input, and each input have only false true. So we say all the combination here, it's all combination is only four. Well, so if we say now it's 4 or three combinations, how to calculate, how to generate all these combinations? I think it's not that difficult, but let's say, okay, can we new? I want new one. Okay, guys. So now what we say, x1, x2, x3, and each all of them have, for example, two value only, which is true or false. Okay, true or false, true, or let's say, okay, no problem. Better to take something else, guys. Okay, let's say the variables not x1, x2, a, b, c. Okay, and this the value of a. It's, for example, only two value. We can say 0, 1, 0, 1, but maybe it will not be clear when we write. So let's say, okay, one, a1 and a2, a1 and okay, b, two case, okay, and two, okay, c1 and c2. So now if I want to generate all the combination, it's easy, guys, not that difficult. Now we have, this is the variables. Okay. So if I want all combinations, based on this, you can calculate it, which should be 2 power, how many? Because it's only two, so it's easy. We can say it's 2 power 3, I think. It's right. Yes, it will be 8. So it's 8. So we start with A1, should be B1, and then C1. So we can continue like this, and then we can say, okay, A1, B1, and the other option of C, which is C2. Right. It's easy like this, but it's okay. Maybe the easy one, which I can read 4, since we have A, we can just write it's 8-1. This is 8, right? And then 2, 2, 2, 2. After that, we come to this, which should be 2, 2. So B1, B1, B2, B2, and then, okay, next, again, B1, B1, B2, B2. After that, here it should be alternative between C1 and C2. C1, C2, C1, C2, C1, C2. So this is what, guys, this is now all combinations. All combination for these variables. As we see, we have here to test all together. So we need the test cases, not only one value for A or B. No, we want these test cases now. So to test this, we can say exhaustively. That means all the possibilities. We have these test cases. We see 8 test cases. Okay, so this is the how to generate the all combinations. So here the same idea, but it's a little bit big because we have how many now variables? It's 4 variables. So the same idea. So this is all combinations. So let's see the next method, which is the pairwise. As I mentioned, pairwise, we have to test only all pairs. So we have here, for example, this pair should be included. Okay, and this pair should be included, and this pair should be included. But you don't have to test all together. You don't have to test the 8 or the 12 or the 40, 24 options or 24 combinations. You don't have to test all. We just test the pairs. Each pairs, we have now the variable A and the variable B. So if the variable A take two values, that means the pairs, how many pairs these two variables or two inputs have? These have 4. So I have to test these 4. Whatever I put it in the test cases, I put it here, anywhere, but I have to test these 4. So the second combination, which is what? The B and C have, for example, 4 pairs. I have to test these 4 pairs. Whatever it's where, anywhere here, it's okay, but I have to test it. The third also will be, for example, if I have only 3 variables, as based on our example. So A, B, C, and C, and and B and A, because A, B will have AC. Yes. So this is three combinations. Each combination have 4 possibilities, 4 pairs. Each combinations have 4 pairs. So I should to include these pairs. So I will show you guys. I will show you. So this is the idea of the pairs. And you see here, there's an example here. They told you that, okay, if I use the pairs, if you see here now, we have 4 parameters. The exhaustive testing, or we can say the all combination, is 24. So if I have 10 variables or 10 inputs, the exhaustive testing, it's, you see, it's how many millions? It's a lot, right? But if using the pairs, it can be reduced into 177. And this is actually, it's used sometimes if you don't have time. But if you have time, you can go for 3 pairs, 4 pairs, like this. They call it 3-way, 4-way, 5-way, until 6-way. So if you test the pairs, if you test all the pairs, you will detect around from 70 to 74 from the defects, and which is good number, good percentage. The rate here is around from the defects. You will detect around 70% from the defects. So it's good. So if you go to 3 pairs, 3 combination, 3-way, so maybe the detection, it will go to the 90 or 95, I'm not sure. If we go to 6 pairs, so if you have, for example, 10 variables, and you test only all 6 pair or 6-way, because we cannot say pairs, when we have 2 pairs, is okay, but 6-way. So the percentage here, it's can be go to 99.9, so which is good rate of detection. So that's why it's good. It's really good methods to test your application. But here also, guys, we just generate the test cases. So let's see how it's work actually. So in this example, it's just show we have now all the pairs is 24, right? When we use the pairs pairwise, it's reduced into 6 pairs only. How it's reduced, as we see here, guys. Now, if you see, for example, we have upper case. If we just want two pairs, which is, for example, the text. The text have 3 value, and the match case have 2 value, which is yes or no. So here we have, if you find any, this is the 6 and 3 will be, we have maybe 6 pairs. 6 pairs, right? We have the first pair, which, for example, upper with yes, right? This is upper with yes, is correct. Upper with no, is correct. We have the second one, which is low with yes, low with no, and mix yes and no. So if you see here, all the pairs, it's include. The same thing now, if we go to the same is found. It's found. The same thing, the upper with yes, the upper with no, the lower with yes, the lower with no. So here just the pair. We don't need to cover all the combination, only the pairs. So how to reduce this number? How to reduce it from 24 to 6? So the next is how to reduce this one. So let's see now. We have 3 input. This is example how to reduce it. Okay. 3 parameters or 3 inputs, and each input, this one has 2 value, and 3 value. So all pairs or all combination, this one, because we use only 3 parameters or 3 input. So how we can reduce it, guys? See now the next slide. Okay, see the next slide. I generate all inputs, all pairs. See now, I say we have A, B, C. This is the input. So how many combination we have? We have A and B. We have A and C. So this is A and B, and this is A and C. And the last one we have B and C, and this is B and C. So first I will generate all combination, all possible combination for these 2 pairs. All combination of these 2 pairs. So okay, this is normal. As we see here, we have only A1, A2, B1, B2. So we have here the combination here 4. For AC, we have AC here. This is A and this is C. Since we have here will be A with A1, A1 with C1, A1 with C2, A1 with C3. So this is the second one. So A with all, and then A2 with all. So this is the second pairs. So now I'm generating the pairs. Here I'm generating the pairs of the third combinations. So now when I select the test cases, that's why here is wisely, where is the word? I don't know where, but I write it here. Wisely, you should wisely generate the test case, select the test cases. So now the first one, for example, I select this is the test case. This should be the final one. So now I select, for example, A. I will see which one is this. A is already covered the first one, already covered the third, the first one from the first one, also from the second combination, also the first one from the second, from the third combinations. So this is okay. Now I select any other one. For example, I can select A1, B2, and A1 and B2, and for example C2. So I will see, I put it here, and I will see how many it's cover. So I will select every time one test cases, but this test cases should cover one pairs. Okay, so every time I will select another one, until I cover all of these. So now I just show you for 2 only. I mean this the first one, the first test cases, and then the second one, which is with Dutch, the second test cases. And then I have to go through all of them like this. It's not necessary everyone is cover the 3. Sometimes it should cover only 2. So, but still it's okay. That's why sometimes we have test cases with, for example, 6 row and sometimes with 7 row. So it's not necessary to be the minimum one. So this is the idea of the pairwise. Here is the same idea. Maybe if you have time, you just read it. This is the same idea of three-way, which is 3 wise, for example. So we can say it. That's one because this is two-way. They call it two-way. Yeah, I write it here, 2-way. Okay, so we have also 3-way, we have 4-way, we have 5-way. So this example with 3-way, and the same idea here, but we use different way. We have the 3-way. Now this is the combination of 3-way because 3 variables should be, right? 3 variable. So if you see here, this is okay, don't care. This is don't care or doesn't matter. This is don't care, this don't care. So what we care, I'm caring about the other combination, which is the 3. For example, here I'm caring about A, B, C. Here, A, C, D. So I want any test cases that cover all of these combination without the white one. So of course now it will be reduced and it will be less than the all combinations.